My name is Joe Grand, and we're going to talk about hardware hacking today. How many of you guys have been to Roots Asylum before? So like maybe half. How many have seen my hardware hacking talk from last year? The same people? Okay, cool, well thanks. Okay, so, oops, must be noon. So this talk is called Using Superpowers for Hardware Hacking. And for those of you guys that have been here in previous years, normally I'll talk about the hardware hacking and sort of hardware hackers who kind of are forefathers in hardware hacking, guys like Thomas Edison and people that were experimenting with electronics and doing things that nobody expected could be done with electronics. So I'm going to do a little bit of intro of that, but this particular presentation is something that I just gave at a conference on Wednesday at a place called B-Sides, which is another one of the more adult-focused hacker conferences. And it's all about kind of using cool superpowers, so technology like lasers and X-ray to help you figure out how electronics work, help you kind of look inside of electronics in a way that you wouldn't normally. So I thought that was sort of cool, is to just kind of share, instead of doing the same old thing every year, sort of expose you guys to like, look, this is sort of like the latest stuff, what you can actually do if you can get access to really cool equipment. Once you know how to solder, you're going to want to learn the next thing. So you keep going down this path, and it's the same way with me. I'm an old man now, I have 2 kids, and I'm always learning, and I always want to learn, and that's the hardware hacking mindset, is always want to learn something new, no matter how old you are. So for me, it's like, all right, I've been figuring out how circuits work for a long time and designing stuff, but now I want to look at all these cool new machines, because there's always something newer out there that you can learn from. So let's start this. I have lots of cool pictures and stuff. So a little bit of background. I grew up a long time ago with just a kind of addiction to electronics. I loved electronics, I loved computers. When I was 7 years old, which was way back in 1982, I had an Atari 400 computer, which is a super awesome computer, and just a very, just kind of started exploring using a modem, which I could connect to other computers, sort of a very early form of the internet, and started just talking to people and learning things, and discovered the hacker community. So when I was really young, I got involved in the hacker, the real underground, where back then it was like you had a handful of people in each city or at like each school that maybe were into computers. And of those guys, maybe there was a handful, a few of those that were into kind of kind of electronic mischief sort of stuff. And so I, just got involved in the hacker community early, the hacker mindset, and just have always been around electronics and computers. I ended up being on a TV show a few years ago called Prototype This, which I think I've given a presentation at Roots Asylum about, but basically it was 4 guys building prototypes of these crazy projects, and I think I have 1 or 2 of them in the slides. And that was a great time to actually, for me to learn stuff and to use someone else's money to be able to build stuff. And it was a really good time, sort of sharing, my love of electronics and hardware hacking with the, with the world, basically. But really, what I basically do is I design electronics. I teach people how to defeat security of electronics, so hardware hacking to test security features, and basically just go around and kind of share as much as I can with other people, because that's the other part of hacking, is not just learning something on your own, but then teaching other people about it. It's this sort of sharing, because people like us that think a certain way, that always want to explore and always want to modify things and always want to learn, sometimes we get in trouble in school because we're not thinking the way the teacher wants us to. Sometimes we maybe get in trouble at home because we don't quite listen to our parents. That type of mindset is important to share, the things you learn with the other people that think your way. And that's why Roots Asylum is good, that's why DEF CON is good, all these hacker groups, all these hacker clubs, all these hacker spaces. Because to us it's what we know, and most of the world doesn't think like us. So it's sort of our responsibility to make the world better by sharing what we know with each other. All right, so a little bit kind of intro to hardware hacking. If you guys have seen this talk before, you've seen some of these examples. I just like these ones. Hardware hacking is lots of different things. It can be creating something new. And these few examples I have are some of my favorite from when I was younger. So the thing on the left here is my attempt at being able to spy on people by shining a laser at a window and then capturing the vibrations on the window to recreate the audio. So I could like be outside of somebody's house and shine, a laser, say at the kitchen window, and like hear what the family's talking about inside the window of the house. And I'd heard that the government could do this type of stuff, which they do, just a much higher tech version. There's actually just some research that came out that you can actually use a camera, shine on an object, like a bag of potato chips or something, say inside of a room, and capture the tiny movements in the bag of potato chips and recreate that back into the sound. Because your sound, as you're creating these sound waves, will cause other things to vibrate, and then you can pick up those vibrations. So pretty amazing. But this was like my attempt at it. And I put it together, and like it sort of worked. If I turned the radio up really loud, I could kind of hear the audio. But for me, it was like, can I do it? Can I create something like this? I don't have $100,000, however much it would cost to buy one, and even if I did, I probably wouldn't be able to because I was 15. So it's just something fun, and that's part of hardware hacking. Creating something new, trying something, even if it fails. I learned a lot about how to capture laser light and how to amplify the signal and all of this stuff that ended up coming in useful later when I became an actual professional engineer. So it was sort of fun. The one in the middle, another one of my favorites, is a really bad picture because back when I took this picture was with like a camera with like real film and stuff, and that didn't focus very well. But this thing was a little circuit that I put inside of a cough drop box and brought it into school and turned it on. And what it does is create a really high-pitched sound, sort of like a whining sound. Sort of like if a TV is on or something, it's like a really high-pitched, really annoying sound. And the thing about high frequencies is you can't tell, they bounce all over the place. So you can't really tell exactly where the original source is coming from. So I brought this into the room, stuck it on my desk, pretended I was sick. I was like, and the high-pitched sound would go, and then the teacher would be like, "What is that sound?" And all my friends and the kids in class would be like, "Oh, my ears, it's so annoying," and no one could ever figure out where it was coming from. And I eventually did get in trouble for it, but it was totally worth it. So that's hardware hacking is designing stuff. The thing on the right is a very simple device. One of the first circuit boards, actually the first circuit board I ever made. This thing would plug into a telephone line. Of a landline phone, which most people don't have anymore, and it would let you use the phone like normal, but if somebody tried to call into the house, it would appear as a busy signal. So that way, like, teachers couldn't call, or the police couldn't call, or people I was worried about calling my house couldn't call the house. It was awesome. Eventually my parents found out about that too, and then we actually used it, so it was sort of a mischievous thing for me, but then we actually used it for real to turn it on during dinner so we wouldn't get sales calls and spam calls and all of that stuff. So it actually, was sort of a mischievous kind of thing that I just wanted to do that turned into legitimate use, and that's, also part of hacking. So those are some things from back in the day. A more recent one, creating something new. This is from Prototype This, from the TV show, which is on Netflix now, I think on DVD only, so you have to, sign up on the list to get it. It's also online on YouTube and various other places. This was one of the 13 things that we built. 30-foot giant boxing, or 10-foot giant boxing robots that would fight based on the movement of players outside the ring. So I'm there on the right. I have boxing gloves on with accelerometers in them that can track motion. Sort of like now we have them all built into our phones and into our wearable pedometers and stuff. So we put wireless ones in our gloves. So as we punched, we could capture the movements and determine if it was, a jab or an uppercut, and then control the hydraulics of these giant robots to actually start beating each other up, which was totally awesome. We also had on our backs things called glyphs. So I think there's some toys that do this now. It's called augmented reality. There's like some toys or t-shirts or something where you can like put your smartphone up to it and it will show a picture or something. Have you guys seen that before? There's like toys that do it. You can put a toy, like put your phone onto a toy, or like a webcam on a toy, and it will show up something. Doctor Who TARDIS? So there's lots of sort of augmented reality that are using this kind of vision system and then create some alternate world or whatever. So we use these little images on our back to track if we're moving left or right or forwards or backwards, because the computer can calculate, if it knows the image and it sees a change, it can calculate the difference and know which way we're moving. So we use that to move the robot around. So super cool episode. I'm not going to tell you who won the final, but just let me tell you that I helped build the robots. So that's just, purely just creating something new. Hacking is all about doing something that's never been done before. And if somebody says you can't do it, your response should be, I'm going to show you that I can do it. And then you go and try to do it. Not to listen to somebody. If they say you can't do something, you don't say, okay, and you walk away. You say, I'm going to show you that I can create something. I can do this. Modifying electronics is another form of hardware hacking. Taking something that exists and then changing it to do something else. And we see this a lot, with Charlie Miller's talk on car hacking. It's taking the car, modifying it, or spoofing information, or doing something to have it do something it wasn't intended to do, right? Like do the speedometer with the brakes, or whatever it is. So in this case, this was a garage door opener. How many of you guys have garages in your house? How many of you guys have like a garage door opener system that you push the button and, yeah, okay. How many of them look like this? Well, without the electronics, like you just push the button. Yeah, okay, so most of you. So this is a system, maybe half of the systems now use this type of system, where basically you have a bunch of switches on the transmitter, which is what I'm showing here. A bunch of switches you would set. There's 10 switches, so you can set each switch on or off. That will set the password of the device. And then you set your receiver at the actual garage door with the same password. You push the button. If the passwords match, the garage door opens. Sort of a very simple, very weak type of system. And the reason it's weak is because there's only 10 dip switches, which means there's 2 to the 10 on and off, 2 to the 10 possible combinations, which is 1,024. So you could actually, that means there's 1,024 passwords for any system that ever uses this. You could sit outside of a house if you wanted to and manually go through all the different combinations. 1,024, maybe it would take you, I don't know, an hour or two if you're really good. Maybe a few more hours, whatever it is. The point is that it's a brute forceable type of system. And brute force, if you can brute force a password, that's really bad. That means it's completely wide open by taking guesses at everything. So in this case, I said, okay, well, I'm not going to sit there and switch all these dip switches. I'm going to create a circuit to do it for me. So I built a little circuit, made a little circuit board for it. This was, I think I was 1994. I think I was like, I don't know, 17, 18, something like that. And built this circuit to basically go through automatically all the different combinations for me. And then I just hold the button down, cycles through all the combinations, and then whatever garage door that uses this particular transmitting system will open. So that's modifying electronics. I never used it for anything malicious, but it was fun to go around the neighborhood and open the garage doors and then show my parents, like, look, we can open the garage door. And their response to that was sort of like, good job, like they didn't really do anything about it, which is very typical actually of like what hardware vendors do in the real world with security researchers. Is you show them a problem and they're like, okay, yeah, whatever. They don't do anything, or they try to throw you in jail, like the guy from the EFF was talking about. So it's a very kind of weird area. Here's another fun one, another modifying electronics. This was a Tooth Tunes toothbrush. How many of you guys have one of these? Nobody? I know a lot of kids in high school. I just taught a high school computer security camp over the summer, and like a bunch of those kids had these Tooth Tunes. And this was basically, you push a button on the toothbrush, it will play a song for 2 minutes, because you're supposed to brush your teeth for 2 minutes in order to get a good cleaning. And it plays a song through the toothbrush, and when you hold it to your teeth, you actually, like the toothbrush head kind of vibrates a little bit and acts as a speaker, and when you touch it to your teeth, you can, through bone conduction, actually hear it in your ears. It sort of vibrates in your jawbone a little bit, and you hear the song in your ears. So it's actually pretty cool. So you brush your teeth, you hear the song. When the song stops, you stop brushing your teeth. So I bought one because I thought it was really cool, and it was I don't remember the guy, Teo Cruz. I don't know, Dynamite. That song Dynamite from like 2 years ago or something. It was really popular at one point. I don't know if it still is. But I have other songs that I prefer instead of Dynamite. So I said, all right, I'm going to modify that toothbrush to play the type of music that I like. So I built a little circuit. The circuit that was in there had a hard-coded song, so I couldn't go in and just change the song of that circuit. I had to take that circuit out, create my own circuit that would take in a little micro SD card with any sort of WAV file on it, or like MP3 file. But it was a WAV file, so it was sort of it was a different type of encoding. With whatever song I wanted, stick it in there, and now my toothbrush would play whatever song I wanted. So I've gotten it to this point of like a little prototype with the circuit board, or with the breadboard, and I know I said this last year, I still want to put it on that from that breadboard and shove it into the actual toothbrush. I just haven't gotten around to doing it. But that's modifying electronics. If you don't like how a product operates the way it is, go ahead and change it and have it do something else. It's your right to do that. So testing security, I have 2 slides on this. Since we're at a hacker conference, a lot of us like to look at the security of products and how it's protecting somebody's information or how it's preventing you from doing something if there's a password. And that's a really important part of hardware hacking, is testing security, especially because a lot of people that design products think that they're designing them properly. They think they're secure, but they're not. And since we're hackers, we're the few people that actually understand the technology. It's our responsibility to find the problems, tell people about them, and have the problems get fixed. So in this case, I like doing it on hardware products. Here's one, a parking meter from San Francisco, where I used to live, had a smart card based system. So you could go and buy, it would take money as well. You can see the coin slot there, but it had a smart card system. You'd go to the store, you'd buy a smart card for $20 or $50 that had your money on it. When you wanted to use the parking meter, you put the card in the meter and it would show you the current value of money, and then it would start adding time to the meter and taking money off of the card. Then when the card ran out of money, you would throw it away and you'd buy a new card. I'd never worked with smart cards before, and I said, oh, this would be a great idea to try to figure out how the system works. I'm kind of curious. So I figured out a way. I created a little board and hooked up a bunch of stuff where I could monitor the communications between the smart card and the parking meter. So basically like eavesdropping and listening to all the digital data that was going back and forth. Eventually figured out what was going on and then modified the data in the way that I wanted to basically have what I thought would show the maximum value possible for this particular system. And I ended up creating my own custom smart card, which is in my hand in that picture, which had my own code running on it that basically would emulate this smart card, the real smart card. So I created an emulator, modified the byte, modified the data, and I'll show you what happens here. So all I did was set some values of how the maximum card value was set on the card, and I'll show you what happens. Can you guys see that? I have $999.99 of free parking. In San Francisco, that would last about a day. But that was a mistake by the vendor, the person who made this product. They weren't thinking about setting the maximum limit of the card. Because the maximum that they sell is $50, so why doesn't the parking meter stop it at $50? That was a mistake on their part. I found this. I gave a talk at Black Hat about it. I gave a talk at DEF CON. They did actually, now if I use that card, it doesn't work. It will only work now if the card says it's $50 or below. So they sort of fixed the problem, but they didn't really, because I can still just use a lower value. But it's sort of like, that type of thinking people don't think the way we do. And whoever designed this parking meter wasn't thinking about somebody modifying the smart card. They were thinking about somebody shoving gum into the coin slot, or beating it with a baseball bat or something. They're not thinking about the high-tech sort of issues. So it was fun to meet with the city and show them this stuff. So here's another one of testing security. I showed this last year too. This was done by a friend of mine named Barnaby Jack, who gave this presentation a few years ago about hacking ATMs, cash machines. Because we've all secretly wanted to be like that guy in Terminator, or Terminator 2, I don't remember. Going up to the ATM and doing some stuff and having a bunch of money come out of the machine. That would be awesome. If it wasn't illegal, it would be totally awesome. So Barnaby decided to get an ATM, figure out how it worked, figure out how to get into the device, found out that there was a way that you could actually connect to an ATM, either over a modem, so over a telephone line, or over Ethernet. Because these things all have to communicate with the bank. So they have to be connected somehow. So he figured out a way to connect to them, or through that same interface, and found out that he could upload new code to this computer. This is essentially like a Windows CE computer. So he figured out that he could upload his own programs to the computer and have it run his own programs. Just like you put a disk in a machine or you run some app. Same sort of thing here. He's just loading new stuff. So he found a few security problems that enabled him to bypass password protection and stuff like that, load his own code, And he did a whole bunch of stuff, but this was the coolest one, so I'll show you the result of this. So I don't know if you can see on the screen, it says jackpot, and it's playing a little bit of music. Gets better. And then the money starts coming out of the machine. So he had to wait a year before he actually released this information so the ATM vendor could try to fix the problem. So, you know, people would just go and steal all the money. But this was, you know, just an interesting one. If a good guy can do it, and he's telling people about it, there's definitely bad people out there taking advantage of this stuff. And that's why it's our responsibility. It makes everybody safer if we go and say, hey, there's a problem, you should fix this so you don't get ripped off. Because if you get ripped off, the bank service charges are going to be more, we're going to end up paying more money, everybody's going to be at risk. So, you know, we want to make the world better, and the way that we can do it is using what we know and share that with people. All right, so that was a little introduction to hardware hacking. And I'm going to go a little bit into the next part, which is using these superpowers, because this is sort of the cool stuff I'm working on, the latest stuff I'm working on. And I realized superpowers aren't just for superheroes. There's lots of superheroes out there on Wikipedia, and you know, they have all sorts of crazy powers of stuff. But there are ones that use laser. I don't remember the name, laser. Does Superman use lasers like on his eyes? I don't know. There's somebody that uses lasers to burn stuff with his eyes. Sound waves, there's got to be somebody that uses sound. And X-ray, of course, every superhero wants to have X-ray vision. I know all of them don't, but some do. So we can use those to look at electronics and figure out how they work and give us clues about what's going on with a piece of electronics, because that's part of hardware hacking, is sort of gathering information about something and then figuring out how to take advantage of it to do something. So this will just show you some of the kind of stuff that I've been doing recently. So I've been working a lot at the circuit board level. So assuming you get access to a product, there's going to be a circuit board. And the circuit board holds the components, physically holds them on the board, and also connects them together with conductive traces of copper. And it's sort of like a sandwich of layers, where you have copper layers and you have fiberglass in between. And normally you just look at a circuit board, it's like a green board and you can't really tell what's going on. But there's a lot of stuff going on. And this is sort of an area, I like to say that like a circuit board is sort of like source code for a physical electronics design. And it's a very kind of new area, at least in the hardware hacking world. You know, people are looking at firmware, people are looking at components, but now the circuit board is the next level down. So you can see on the right, that's like a 16-layer circuit board. Usually you have like a 2 or 4 layer board of different copper layers, 16-layer. The iPhone board is 10 layers, super thin 10-layer board. I actually used one of those for some of the experiments, but just very complex. That picture on the right is like, it's like an Indonesian Dutch cake called spekkoek. I don't know if I pronounced it right, but it's like a layer cake. And I was in the Netherlands and got that served to me, and I was like, oh my god, it looks just like a circuit board. I love it. It tastes much better than a circuit board, though. So here's like what a normal circuit board looks like. This is one from a class that I teach at Black Hat. And there's a bunch of different layers. So you have your copper layers, and you have your substrate, your non-conductive layers, but there's other stuff as well. You have like a silk screen that kind of shows information, a solder mask, which is what makes the board green, or other colors. Last year, the Roots badge was black, I think, black or blue or something like that. So you can use different colors, and that just protects certain areas. But when we're hardware hacking, we need to deal with getting through that protective coating to get access to the copper. Here's some stuff with lasers. How many of you guys have used a laser to like engrave your phone or your computer or anything like that, or have anything laser engraved? A handful of people. Okay, if you haven't, you should check it out. You should go to like a hackerspace and get stuff engraved, because lasers are totally awesome. This picture here is like a pretty big one, but they have really kind of small hobbyist lasers that you can use and etch things and cut out shapes on wood or on plastic, and then you can build stuff with them. So this particular place, this isn't mine. So all this stuff I went to companies and said, hey, I'm doing some work, can I pay you to use your machines? And they all said, sure. So this was a laser, and you can see a little bit moving back and forth. It doesn't really look like much when it's happening, but it's actually burning the surface of whatever it's shining on. So it's not like a laser, like a red or green laser you'd shine, at stars or at, your friends or something. This thing will burn stuff, which is really cool. I don't know. I thought it was really neat. So normally it's used during to create circuit board, kind of flexible circuit boards, and to mark things like engraving. But I use it to see if I could remove that thin layer of solder mask to see if I can get access to the layer underneath, and I could. Just kind of shining the laser on it, and that was kind of fun. And then, there's probably all sorts of other stuff you could do with a laser, like popping balloons and things. But they're super dangerous, but also, if you use them right, they're kind of fun. Here's another one I wanted to see. Does anybody recognize what game that's from? I would be blown away if anybody knows this. Even though it says it right there, but don't read the words. What was it? Nope. And does anybody remember Moon Patrol? Yes. Okay. How old are you? Okay. She's old enough where she's not telling, which means she's probably my age. Moon Patrol is a game from a long time ago, 1984, I think, or something like that. But a very cool game. And I decided to use it for this project just because it had 6 layers of graphics. So as you drive that little moon buggy along the surface of the moon, the back part moves slower than the front part. So I don't know, it's just kind of a really cool design. So what I did is I created a circuit board that had an image of Moon Patrol on it. And I had for each layer of the circuit board, each layer of copper, I had a different layer of the drawing. So in theory, I didn't know if this was possible. I was like, what if I could use a laser to burn away all of the other stuff, not the copper, but all the substrate, everything else, and see if I could create like a 3D kind of version of this Moon Patrol image. And I didn't know what was going to happen. That's part of hardware hacking, is you try stuff and you fail. There's a lot of stuff I didn't include in any of the work that I'm presenting, just because it was, a lot of stuff didn't work. But this stuff sort of worked, and you can always learn from your failures. But this one did sort of work. So I had 6 layers of the circuit board, and little by little you can go along with the numbers. Like number 1 was just the top layer. Number 2, we etched away just the solder mask. Number 3, we got down a little bit more. Number 4, you can actually see the little moon buggy, and you can see that kind of weave-looking pattern. That's the actual substrate of the circuit board. So then we had to use a laser again to get through that substrate, which would then show the city, and then we exposed the whole thing, and it sort of burned a little bit. But it was sort of just kind of a fun experiment. And now you can actually, if you touch that circuit board, you can feel the different layers of the board. So I don't know, I thought it was kind of fun. Using sound waves. This was one that I'd never heard about before, and I was doing some research, and somebody said, hey, what if you use this thing called acoustic microscopy, which is basically getting images like you would with an X-ray, except instead of radio waves going through your body, it's sound waves. So it's really high frequency sound waves. And normally that's used during, for engineering stuff, when they're making computer chips and looking for failures if something doesn't work. You can get very good resolution and find certain types of failures. But I was like, wait, what if I could use it for looking at circuit boards or other things? And I'll show you what I ended up really using it for. So basically what you have is you're sending sound waves, basically like with a speaker, through the thing you're looking at, and then you're capturing it on the other side. Sort of as like an X-ray. I don't know if I don't have a video of it. But this one in particular, sometimes products, I don't know if you've ever seen this before, if you've opened something up, but sometimes products have things covered in glue or epoxy. And that's done by vendors when they're trying to protect something that they don't want the user to look at. So when I teach adults about hardware hacking and how to analyze products, I say, look, if somebody's covering something with glue, that's probably a good thing that you probably want to go take a look at that because they're trying to protect it. Right? It's like putting a lock on a door. If there's a lock on a door, people think that there's, whatever's behind that door is worth protecting. Same thing here. So then there's always this sort of opposite thing of well, if you leave your door unlocked, then people are just going to think nothing's worth going in there for. So you never really know. But in this case, I see epoxy on a part, and I say, okay, I want to know what's behind it. Because part of my process is to figure out exactly how the board works. An X-ray sometimes will let you look through glue and look through epoxy and stuff. And I might have some pictures of that. But it doesn't work all the time. It doesn't let you see silicon. actual integrated circuits, actual computer chips, actual real tiny things made of glass and other types of materials. It sort of shines right through. X-ray just shines right through them, and you don't get any. The material doesn't absorb anything, so you don't see anything on the X-ray. But sound waves actually bounce back, and they can bounce through, and you can see what's underneath the epoxy. And in this case, so the picture on the bottom with the big X next to it, that's what this thing looked like on the X-ray. This was a thumb drive, little flash thumb drive that I got at a conference. And in the X-ray machine, all you could see is the chip that was on the other side of the circuit board, which I could already see. I didn't need any superpowers to do that. But on the other side, you couldn't see anything else. And the person who was running the X-ray machine was like, well, I guess there's just nothing under the epoxy. And I was like, well, why would that be? And she was like, I don't know, but that's what it shows on the X-ray. Because she was just so focused on only trusting what she saw on that machine, not questioning, why isn't there anything there? That's weird. That's my job. So I said, well, that's weird. That doesn't make sense. I went to this guy to shine these sound waves through it, and we could actually see that little rectangle up there is an actual flash memory chip with no pins coming off it. Like the one below, you can see little legs that connect to other things. This was the chip itself with tiny little wires connecting to the circuit board and then covered with glue. So part of my process, if I can get access to that memory and copy the data out of it, then I can continue on with whatever I'm doing. In this case, since it's a thumb drive, I could have just stuck the thing in my machine and copied the data off. But I wanted to know what was under the epoxy. So sound waves can do that. Kind of just a neat way to give you images of things that you might not normally be able to get to. X-ray. How many of you guys have had X-rays before? Almost everybody. If you haven't, you probably will at some point. Or how many? Yeah. How many of you know somebody who's had an X-ray? Oh, come on. I know all of you guys have. Okay. So X-rays. Normally if we hurt something, we break something, we go to the doctor, we get an X-ray. And it's always cool, or the dentist or something. And it's always fun to see, what your arm looks like when it's broken, or what your, teeth look like or something, right? It's sort of cool to see like an image that you don't normally get to see. You get to see through your body, and you get to see your bones that you can't see. We can do the same thing with X-ray on electronics to see what's inside. Whether it's a very tiny thing, or whether we just want to see through epoxy, or see through a product before we try to open it. Like how many of you guys, when you go to the airport, you try to look at the screen of the X-ray machine just to sort of see what things look like, right? It's fun. You get like seeing things that you don't normally, in a way that you don't normally see, is kind of exciting. So I wanted to do some stuff with X-ray, which in the electronics world is usually used to make sure that components are soldered onto the board properly, especially with very complex parts. Like if you open up a phone these days, or open up some sort of like really expensive type of electronics, like the Chromebook or something, you would see chips that have no connections, because all of the connections are actually underneath the component itself in little balls of solder, like a whole matrix of solder balls. Those are really hard to work with. So these people that manufacture electronics need a way to look through the board and make sure that the part's been soldered on properly. So they have access to X-ray, which means we have access to X-ray, because we can go to these places and say, hey, can I rent some time on your machine? And they'll say, sure. So now you can put stuff in the X-ray machine. I just happened to put circuit boards in, but I really should have brought like all sorts of other stuff to X-ray, because it would just be really fun. Here's what an X-ray machine looks like a non-medical X-ray machine. And it just has a giant chamber inside, and you put stuff in there, and then somebody turns on the X-ray, and it captures an image on the backside, and sometimes the material will absorb X-ray and sometimes it won't, so we can sort of see that on the final image. So for hardware hacking, why do we want to do it? One of the things that I was working on is figuring out different ways of getting access to circuit board layers. Because if I have every individual layer of a circuit board, I can then recreate that into a design and then figure out how the electronics work. So one thing I wanted to do was see if I could put it in an X-ray machine and then look at what's inside of each layer of a circuit board. Here's one that I pulled out of like a pin pad device. So like when you use your credit card in the store or something, you have to enter in, or your debit card, you have to enter in your PIN number, or your parents enter it in, or whatever, or they tell you to do it or whatever. This was one of these devices I bought, opened it up, found this cool circuit board in there that didn't look like it had any connections on it at all. It just looked like sort of a piece of circuit board. But when I put it under an X-ray machine, you can sort of see like a lot of squiggly lines and stuff. And it basically was 4 layers of this crazy looking maze that I don't exactly know how it was designed, but they were trying to make it like a security feature, like a some sort of mesh that you had to break through in order to get down to the next level of the circuitry. So if I was continuing down this path, I would say, okay, I want to figure out how how that part works, and then see if I can somehow modify the electronics to defeat that security. And that's part of hardware hacking. This was a kind of a really neat surprise to actually see that, because I had no idea what was inside. Here's another one. Sometimes you just want to figure out where connections go from a board, so you can do that. Here's some pictures of, there's an iPhone board. How many of you guys have iPhones, or your parents have iPhones, or kids? Yeah. Half the people or so. This is what the circuit board looks like inside. It's really small. So sometimes, if you want to see something inside without being able to open the device, because iPhones are pretty hard to open. Apple has kind of closed their whole design. They don't want anybody messing with any of their stuff. So one of the first steps, if you're hacking a piece of hardware like that, maybe that you're not allowed to open, maybe you can only non-destructively look at it, throw it in an X-ray machine and kind of see how it was designed, see if there's any areas that you might want to go after. But it's all about just using technology to get more information about a product. And then this one, CAT scan. How many of you guys have had a CAT scan, like a 3D X-ray? I think you normally have to go into like one of the tubes and it spins around. Is that MRI? I don't know, one of those anyway. Okay, so a few people. Most people don't get CAT scans, at least as the first line of kind of figuring out what's going on. So CAT scans are done, which are basically taking lots of 2D, two-dimensional X-rays, just like we showed pictures of, just lots of X-ray images, and then lots of computer processing and math and stuff to basically give you a 3D view of whatever the thing is scanning. So it's almost like a 3D scan that you can look into. It was super, super cool. And I had wanted to, again, look at different layers of circuit boards. So I brought a bunch of circuit boards to a place to kind of check this out. The machine looks a lot like the other X-ray machines, just had different software running on it. And I don't know if you noticed, the other guy also had a block over his head. So I don't know, everybody that seems to run these machines has a square head. So here's sort of what the system does. I have a kind of sped up view, but you can see the X-ray head kind of moving as it moves over the image. And I think we took 360 different pictures and then lots of math to put it back together to look at the different images. Different layers of the circuit board. So here's we have each slice of the circuit board that we're looking down through, going through each layer, and then we can start to see some pieces of the circuit board come up. Like here's the top layer, it happens fast. There's the top layer, there's the second layer, then we go through the middle of the board, and then the third layer, and then the fourth layer. So now we can see all the layers of the circuit board without having to touch the circuit board at all. Like, that's pretty awesome. That would be like figuring out how your software works without having to touch your software. It's like just knowing what's going on without having to do anything physical with it. You wouldn't even, I don't know, it's just like a really, really, really neat thing. So that was a cool technology. And this type of stuff is known. Like, people who design circuit boards or deal with this stuff all the time are like, yeah, big deal, you're using X-ray. But our community doesn't really know about this stuff. And that's why, I want to try to share it with people. So here's a final result. So the bottom pictures are what the actual circuit board design looks like. Because these were done with the circuit board that I had designed. So I knew what it looked like at the beginning. So the ones on the bottom are the actual four different layers. And then right above it are the images that we got through slicing, looking at the different slices of the board, and they match. So that's kind of fun. So if we know, those top four images, if we could lay those on top of each other and start playing around with the computer, being able to look through the different layers, and then you can start tracing things out and seeing how things connect. And then when you learn enough about electronics, you figure out what those connections mean and what the chips are, and then you figure out how the product works, and then you can go ahead and modify the board, add new functionality to it, or whatever you want. So that's basically what I've been up to, and a little bit of introduction of hardware hacking, but really it comes down to a few things. One of them is don't be afraid to open things up. If you have a piece of junk electronics, or your parents upgrade their phone, or you have an old computer or something, or you go maybe your school's throwing something out, take it home, if you're allowed to, open it up, see what's going on inside, take out the circuits, take out the chips, take out the components, build something with it, or just kind of learn about what's going on, just have fun. But opening things up to see what's inside is just a huge thing. That's all, that's what you want to do, is just learning and just see what's going on inside. Experiment, don't be afraid to experiment with different things. Just like I didn't know what was going to happen when I put my circuit board in an X-ray machine or put it in the Acoustic Microscopy machine. I had no idea. But that's part of the process of hacking, is learning and experimenting. And if you fail, that's okay. That's part of it. You learn from that failure. You go, okay, well, how come the X-ray didn't work on that thumb drive and sound waves did? That's part of the learning process. You're never too old to learn, and you're never too young to start hacking hardware. If it's something that interests you, lots of different resources online. You can get some really cool electronics kits to build. There's something called snap circuits. That's a really fun thing for kids. You can kind of build projects with snappable components. But again, just sort of collect stuff, open it up, see how things work, play with it. Don't be afraid to break things, unless you're, as long as you have permission. So that's it. That's my presentation. So we have some time for questions if you guys have any questions or want to see other things or anything. Any questions? Anybody? Oh, here's one.
Getting easier nowadays or harder? When you started, the systems were this big. Now it's
Yeah.
like
So is hardware hacking getting harder? And the answer is yes. As products get smaller and smaller, the components get smaller and smaller, and more stuff gets crammed into a product and get crammed inside of chips. So it's a lot harder to work with the stuff, but a lot of the technique is the same, the mindset is the same. Thinking about how somebody built the product and how we can defeat the product. So it just changes the tools, but it doesn't change our hacking mindset. Anything else? No? All right. Well, thanks for listening.